Hi everyone. Thanks for the introduction as mentioned. I'm Vincent Kroll. I'm the product manager at Allied Vision and responsible for smart cameras. And I will take with me today to the forest of different wordings regarding smart cams, for example, edge cams, AI cams, and how we try and how we name them and how we different them. So today the content will focus on the Alecs itself, our new product, our smart camera system. But I also want really to go in detail what's the differences between open and closed smart camera systems. So these are the wordings we usually use in all kind of smart cameras. And afterwards, I will introduce you to the mentioned Alecs and its USPs. And afterwards, we will go into the SOMs, so the system on modules, which we use, so especially the NVIDIA Jetson Orin boards and the difference in between, so that a customer or whoever can really decide what is the right SOM for my application, for my solution. Starting with the most famous slide at Allied Vision when we talked about smart camera systems. So the header shows it. Please do not make false comparisons. Talking about open smart cameras, which Alecs is, means that this is a smart camera system which is open for every software which can be used to program solutions. So the product comes without any software. So it's not the case that there is a well-known user experienced optimized front end for the customer. So it's just the bare smart camera with the possibility and the flexibility to use it for each application the customer wants to do. On the opposite side, solutions which have this big environment of software are called closed smart cameras, which are really designed for specific tasks and comes with solutions. So the software is included into the product. That's the main difference. And along to that, there came different advantages and disadvantages with. So talking about open smart camera systems, they are typically based on Linux, and that allows, as mentioned before, an extensive possibility to customize everything because there is no dedicated software with borders, so it's free programmable. And of course, this needs and requires really programming skills by the customers. So mostly the solution providers or system integrators or machine builders are the focused segments and market customers for open camera systems. And there is a wide range of software available. So open smart cameras should be compatible with all of these known software packages and software sub-providers. With open smart cameras, is it possible really to create tailored algorithms to a tailored problem? Closed smart cameras, on the opposite, this is a product which goes more to the end customers, which are really expect dedicated functions like verification, percentage checks, edge analysis, which are already implemented on the device in the software. And hopefully, or the main point is that the flexibility is then really limited and restricted to these functions. Often the providers comes with add-ons and so on to really solve different and dedicated solution, but mostly they comes with a base pack and then it's not really possible to create customizations with them. But of course, closed smart cameras are excellent for specific inspection tasks for end customers in the most cases. To give the overview where the know-how is and where the know-how should be in between closed smart camera systems and open smart camera systems. So on the left side, you see the customer know-how is really high at, for example, solution providers. And that point here. So it's really the know-how is at the solution provider because they know how to really integrate an open system, but the integration effort is then at the customer, at the solution provider. A little bit lower at system integrators, also a little bit lower at machine builders, depending on their background. So, and for all these are the open smart cameras like the Alexes are the right product because they have the skills to program it and to get access to the different SOMs and create everything and bring it together with the software of their choice. And on the other side, when the end customer, really the end user, wants to have a smart camera system, they expect, as mentioned, the functions and also in most cases that it's easy to use, but there is the know-how at the provider and the provider needs to sell directly to the end customer. So there's a lot of effort necessary, for example, with field application engineers to set up the solution. But in between, there is a gap and closed smart cameras fill this. And with open smart cameras, they are more dedicated for the flexibility solutions, which comes with system integrators, machine builders, and solution providers. On the bare overview, here are some parameters which we can directly compare. I will not go to each thing, but to promote some points. The customization, as mentioned, is with the Open Smart Camera System as high as you can, because it's open to software, and you have in that point also the control over the data. This is a little bit restricted with closed smart camera system, but the easy of use and the setup, how easy it is really to bring it to the end solution. Is it easier with closed smart cameras because a lot of points are included here. At open smart cameras, it's necessary to have skills to really bring this product to the solution. This support, as mentioned, needs a little bit or is a little bit higher at those smart camera system because you really integrate them at the end customer at the end to solve the problem of the end customer. So you really need to go into the field and solve the problems. Mentioned that Allied Vision launched a new product. So the Alecs is the new smart camera system, the new open smart camera system, which comes with two main points. So the main interesting thing is that we use the well-known Alveum technology. So we use the Alveum platform and bring this together with an SOM. And this SOM is chosen from us with the NVIDIA Jetson Orin. So we use this and bring our system and allow our system to go into the 25-watt power mode of it. So that means that we, from the design phase on, take a set the focus on the heat dissipation design so that it's really possible to ensure to use high power modes and to enable the SOM, the hardware of the SOM, that it's possible to use it for the customer. Later, I will go in detail what this means. So we came with an Alveum, the well-known Alveum platform, integrate this in our Alecs, and bring this together with the SOM from NVIDIA, and enable also really have the highest flexibility, the highest performance of the NVIDIA board regarding the temperature heat dissipation design. As mentioned, with the Alveum platform, we have a full range of sensors available, not directly at the Alecs. We start with 5 and 12 megapixel, but the effort to integrate other sensors, if the request is there, then it's easy possible for us to integrate it, but it's a case-by-case decision. The other point, and that's really more the focus, that we come with the full Alveum feature set, which is also well known in the market. So everyone have access to it and know the feature set, and you can also use it directly in the Alecs. And the Alecs come with the Gen iCam axis and the video for Linux axis. This is also a big advantage. Talking about the NVIDIA boards, so before I saw the question in the chats, the Terra operations, how much is possible. So I will talk later in detail about it, but with the 25-watt power modes, we enable more hardware of the NVIDIA board, which can be used as others. The NX board with 16 gigabytes comes with a big RAM, and we also have an SSD inside with 128 gigabyte. The other point, which was really important during the design phase, is that we want to come with an industrial environment improved solution. So we come with an IP67 and come with the highest temperature range in class from -20 degrees up to 65 which also underline that the heat dissipation design must be really good. So the temperature data from the SOM to the outer housing temperature is the focus performance indicator of the thing when we talk about heat dissipation. So the data should be really small. With the Alveum feature set, it's also possible to use the Wimber-X. So there's a recovery mode included so that the camera is in each case in a defined state. And as mentioned in the beginning, that it's important to have the compatibility with third-party software, we come with that. So we start with Eurosys libraries, which are onto the device, and this is available as test license in the beginning, but then it's possible to use libraries, not software, libraries to the customer that they can use it for build their own software. Coming to a slide which really compares the different Jetson Orin boards. So as mentioned, we come with the 25-watt power mode, which enable us to use more hardware of the Jetson boards as in a 15-watt power mode. And as mentioned, we have this heat dissipation design. So we ensure that the watchdog into the device will not keep their hand and say, okay, it's too hot, I will throttle down the cores of the GPU and so on. So we are ensuring that 25-watt power mode is possible to drive and also to use different hardwares on the device to really ensure that we can achieve the maximum AI performance. And AI performance is the parameter we measure with the tera operations per second. So this is what you see in the table below. Firstly, I will talk about the left side with the Jetson Orin NX. And the tera operations per second is the amount of, as mentioned, as the parameter said, the operations per second which can be do. And this is just for the GPU, 27 compared to the standard 50-watt mode, it's higher. And there are also some DLA tera operations, which concludes to 67 tera operations per second as maximum for the 25-watt mode. The different cores which are into a Jetson Orin NX 16s are the CPU itself, the GPU, and there is only at the Jetson Orin NX 16 dedicated cores for so-called deep learning accelerators, which are cores which customer can directly use to perform their AI algorithms on it. So you do not need the GPU, you really have the DLAs, so the deep learning accelerator cores to drive there your algorithms with AI. And there is an additional course or with the so-called PVA, which is the programmable vision accelerator, which can be used to drive their pre-processing things of images. So there is a direct contact to NVIDIA libraries, which can be used for drive this both cores. And this separate hardware is just available in the 25-watt modes in these numbers. So both hardwares are also in a lower amount of cores available with 15-watt modes, but in 25-watt mode, it's more. To the opposite, there is also the Jetson Orin Nano, which is a little bit cheaper and which comes with 8 GB RAM, so the half of the NX board. There is no DLA and PVA included, so all processing uses the CPU and GPU. So, and we recommend with the Jetson Orin board that it's necessary to pre-train the model externally because the RAM is not so high. So it's recommended, so it's in general possible, but with 8 GB RAM, it could be not sufficient for deeper and higher AI applications when the training model is too big. And the Orin board also come in standard mode with 15 watt. There are some specific customized solutions possible where you can create your own frequency and performance and core decisions. But as standard modes, the Jetson Orin comes with just 15 watt and allows a little bit less tera operations per second. This is the overview here at that point. So my last slide just here is that we have the Alecs available, and with the NX16, and also the engineers accelerate the project so that we have also the nanoboard available, but the customer need to decide what is necessary for their application. So, and with this slide, afterwards, you can click onto the Learn More. You come to our homepage. If it's possible, I will also send the link into the chat. And there's a lot of information available, the user guide, the specification sheet, and so on, where you can insert, raise your hands and take questions with. And I'm also happy to answer questions now. Thanks for your attention.
Okay, thank you, Vincent. Maybe you can send the link to me and I'll put it in the webinar chat for everyone.
Yeah, that sounds good.
But for now, we have a question. Are you planning to release a Alecs camera version with autofocus?
There is at the moment not directly the plan to do this. We have this in different accessories for other systems. So that's a good hint here that we have this on our mind to consider that in further products.
Okay, another question. Could you expand a bit on the difference between closed and an open smart camera?
Yeah, as mentioned in the beginning, is really the naming that a lot of names are in the market. So, and we decide to not use Edge or AI ready naming. So we decide to separate between open smart cameras without any software for the end user, and the closed smart camera is with software for the end customer, which is really ready to use out of the box. That's the main difference.
Okay, and as you mentioned AI, what would I need to get my own AI-based solution running?
So at the beginning, you need to understand what is necessary in hardware-wise to perform your algorithms onto the device. So the main question is, do you want to train the AI model on the device? So then we recommend to use an NX16 with at least 16 gigabyte RAM on it. And on the opposite side, if not, then you can go with the Nano Orin 8 gigabyte version. And then it's necessary to get access to our device and decide which software you want to run. Most customers have their own software, which is common in the market, but others have the pre-development doing by themselves. And we support in that case that we provide the customer with the right handling of our system.
Okay, there's a question from the audience. Is it possible to deploy a Docker image inside?
As far as I need the question take with me. So at the moment, I guess yes. So I heard about it, but I need to clarify it. So I cannot 100% say yes at that point.
Yeah, I think I will share the link and your contact information in the chat. So friend Lopez can contact you directly.
Yeah.
Maybe. Let's see, maybe one more question. Will there be any additional models in the future? Can you talk about that already?
Yeah, for sure. So we start with the NX16 and so the some with the NVIDIA NX16 and plan that we have after this project to integrate the nanoboard. But yeah, the project team was so energized in that we come with both versions, so both are commercial available for everyone. So that's the start point, and we discuss also to integrate other sensors, but at the moment we need the feedback from the market, which sensors are most interested, and if there's also a need to go with, for example, sphere sensors in smart camera systems. This is also something where we think about.
Okay, as there are no more questions from the audience for now, I'd like to say thank you again, and we will see each other again at the Q&A at the end.